Let's look at this geometric problem. In the cube A, B, C, D, E, F, G, H, with opposite vertices C and E. J and I are the midpoints of the segments FB and HD, respectively. Let R be the ratio of the area of the cross-section EJCI to the area of one of the faces of the cube. What is R squared? So in this problem, we have a shape that's three-dimensional. It's a cube, right? Let's suppose it to be a unit cube with side 1. And now we have this cross-section EI. I'll mark these points. This is EICJ. We have this cross-section. Now the ratio of this cross-section to a face of this cube is R. But don't forget, for a unit cube, each face has an area of 1. Therefore, we know that the area of EICJ just equals R. And another fact that we realize is this EICJ is actually a rhombus. How is that? Because let's look at EF. EJ. Let's look at EJ. It is the hypotenuse of this right triangle EFJ, right? This is the hypotenuse of right triangle EFJ. Therefore, EJ equals the square root of 1 square, that's the square of EF, plus a half square, that is the square of FJ. Right? Don't forget, this J is the midpoint of FB. And similarly, the length of JC is also equal to this quantity. We don't have to calculate this quantity yet, because this JC is the hypotenuse of the right triangle JBC, right? I'll put it this way. It is the hypotenuse of right triangle JBC. Therefore, JC has the same length as EJ. Similarly, we know that all the sides of this quadrilateral EICJ are equal. So EICJ is a rhombus. EICJ is a rhombus. Provided this quadrilateral is a rhombus, we know the fact that we can calculate its area in terms of its two diagonals. So let's connect the segment JI. Let's connect this. This is one diagonal. And the other diagonal is EC. Let's connect this diagonal. So we know that this, I'll write it here. This area of EICJ equals a half of JI times EC. And this formula is very easy to prove, because let's look at a rhombus. I'll draw it here. Suppose this is the rhombus, right? And we have two diagonals. And then let's just look at a half, not a half, but a quarter of it. Just look at this part. Since it's a rhombus, we know that this is the right angle. And by symmetry, all these four parts have equal area, right? So we can just focus on this quarter rhombus. It's a right triangle. And let's assume this diagonal from here to here. Let's assume that's A. And let's assume the other diagonal has a length of B, right? So this quarter rhombus or right triangle has an area of a half times the base, this part, right? Which is a half of B, times the height, which is the length of this part, that is a half of A. Therefore, this equals AB over 8. But don't forget, this is only a quarter of this rhombus. So the area of the rhombus, this area, just equals a half of A times B. And that's this formula, right? With that formula, we can compute the area of EICJ quite easily. First, let's look at the length of JI. I'll use a different color. I'll use a blue color. That's this line segment. Let's look at this length. What is it? So we can actually move up this line segment along this line, JF and IH, in this direction, all the way up to the upper face or the top face of this cube. Then JI would become this line segment, which is the diagonal of the square EHGF, right? I'll write it out. So JI equals FH, and FH is the diagonal of EHGF. That's the top face of this cube. Of course, that's a square. Therefore, this quantity equals square root 2. Then how about EC? I'll use the pink color. That's this segment. What is this length? So we can see that this is actually the diagonal of this cube. And if you remember the formula, you would know that the diagonal of a cube is square root of 3. So I'll write it here. EC actually equals square root of 3. But don't worry if you don't remember that formula. It's very easy to derive that. Because if we connect this line, look at this line, CH, that is the diagonal of a side face of the cube, this line, right? Then the triangle EHC is a right triangle. It's a right triangle. And the angle EHC equals 90 degrees. Therefore, we know that the diagonal of this square CH equals square root 2, and EH equals 1. That's the side of the cube. And we combine these two, actually these three. We have EC equals square root of square root 2 square plus 1 square, which is 3. So EC equals square root 3. Now we have the area of EICJ equals R, which also equals this, right? And with this piece of information, we just calculated. Good. So R would equal a half times square root of 2 times square root of 3, which equals a half of square root 6. And what's the question? The question is r squared. Therefore, r squared equals the square of square root 6 over 2 and square. That equals 6 over 4, which equals 3 over 2. Therefore, the answer is C. If you like this video, please subscribe the channel and thumb up. If you have questions, please comment.